Welcome now to part 2 of lesson 5. We're going to talk about how to find the average value of a function. In order to understand that, let's start first with a really basic example. If I give you the numbers 2, 4, 9, and 13, would you know how to find the average of them? What would you do? I hope you would say that you add them all together and divide by 4. Okay, because we know how to find averages. We did that in like 6th or 7th grade, maybe even earlier potentially. So we know that you just add those up and you divide by how many numbers there are. Now, this is a discrete scenario, meaning we have single data points, and we know how many data points we have. There's 4. It's discrete. Up here, if we're finding the average value, not of 4 numbers, but of a function over an interval, this is continuous, which calculus is a study of continuous scenarios that also are differentiable, but that's another story. So we need to figure out the average of those. Now the concept is the same. We just need to add up all the numbers and divide by how many there are. But there's a catch though, because how many numbers are there that come out of x cubed in the integral from -1 to 2? I mean, yeah, the numbers that come out go from -1 up to 8, but between -1 and 8, there are infinitely many different real numbers. And so how do we add all those together? I mean, is it like infinity divided by infinity, or what is that? Well, let's think about the different ways in the last 2 years that we've added up infinitely many numbers. We've had 2 different ways. Okay, one of them was at the very beginning of pre-calculus. We dealt with sigma notation. And if you had something like I equals 1 up to infinity, that's a way of adding together infinitely many things. That actually is discrete, because you know what each of the values are. We need the continuous version of that, which we talked about maybe 4 lessons ago in the beginning of this unit. That would be an integral. So what we're going to do is we're going to add up all the numbers, so x cubed, all the numbers from -1 to 2, because people, this is a summation function, okay? Well, let's start here. That's sigma. I know it looks like an E, but it's sigma on purpose. It's the Greek letter that relates to our letter S, and they chose that intentionally because it comes from a sum. We're making a sum. Same thing here. This symbol is not an accident. This is a sum. It's a scripty capital looking S, okay? And so we're summing up all those things. And now for the fun part. What are we dividing by? I mean, because there's infinitely many numbers that come out of x cubed from -1 to 2. It's not that at all. What we're going to do is we're going to take the range of our bounds, and we're going to divide by that. This went from -1 to 2. That's 2 minus -1, which is a range of 3. That's how we find an average value. Let's go through the calculation. X cubed becomes x to the 4th over 4. And we are going from -1 to 2. And we're dividing that result by 3. Okay, so let's do it. So I get 2 to the 4th over 4 minus -1 to the 4th over 4, whole thing over 3. Okay, 2 to the 4th, that's 2, 4, 8, 16. 16 divided by 4 is 4. Minus 1 to the 4th is 1. 1 divided by 4 is 1/4, whole thing over 3. Let's get a common denominator. That would be 16/4 minus 1/4 over 3, better known as 15/4 over 3. And if you're bothered by the triple stacker, because we're not at Wendy's throwing down burgers right now, then go ahead and put that over 1, flip it and multiply, and you can get 15, flip it, the 3 goes on bottom, 15 over 12. It would be best if we could simplify that to 5 over 4. That's our average value of the function. Now let's double check what that means in context and see if that's surprising or not. The function x cubed, we know looks like this. And we went from -1 to 2. That's the point, -1, -1. And up here, let me redraw that. Let me get it to scale a little bit better. And that is the point 2, 8. So first things first, is more of this function above the axis or below it? Definitely above. We've got a little section below, more of it's above. And so we probably would expect a positive average value. And they're saying that average is somewhere right in here. Oh, excuse me. That's not to scale either. I've got to get my scale right. Okay, so if we had 8, that means 4 is here, and 2 is there, and they're saying the average is somewhere in here. It's not way up there, because it's getting dragged down by the stuff below the axis, but it's definitely above the axis. So there's an example of average value for us. Okay? Let's do one more. Let's look at an application. Okay, in this one, we've got a car, it's cruising down the highway, and we have a velocity function, where it's speed. Okay? It was going 62 miles per hour for a while, and then it started to have some sinusoidal fluctuations in its velocity. Okay? We're given this in miles per hour, and t is going to be hours since the drive started, so it looks like we're going from 0 to 2. It's a 2-hour-long drive. We want to know the average speed of the car. Now, I've intentionally made this a context, and I've intentionally made it a piecewise, so we can see how this could apply to something real, and at the same time, how it could potentially look more challenging. Not that it's going to be more challenging, but it's going to look challenging. Okay, so let's set up our calculation. First of all, it's going to be a fraction. Do you know what number's going on the bottom? We're going from 0 to 2. Hopefully you know that distance is 2. So that's our bounds range. And now we need an integral. And so we're going to integrate, and we're going to go from 0 up to... Actually, that creates a problem, because we have two different functions here. And so we're going to need, then, two different integrals. So we're going to have an integral that goes from 0 to 1, just like that. We're going to have an integral that goes from 1 to 2. And it might look a little intimidating, but it shouldn't be too big a deal, because they told us the function right here was 62. So 62 dx, or actually, it shouldn't be dx. Do you know what it should be? Not x. 0 and 1 are what kind of values? They should be t. Okay, and actually, this should have been a t, and that should have been a t, and that should have also been a t. Oh, sorry about that. Please make the correction in your notes. Okay, so dt, and then 1 to 2, 62 plus 3 sine of t dt. And now we are ready to do a little bit of integration. So let's do that. Okay, 0 to 1, 62 turns into 62t from 0 to 1. Plus 62t. And then what's sine going to turn into? Looks like it's negative cosine, although I didn't leave space for the 3. So we want to leave a little room for our happy little 3 in there. Boom, there's 3 cosine of t. And that goes from 1 up to 2. And I'm going to make these brackets just so it's really clear what's in there and what's not. And let's not forget this whole thing is divided by 2. Okay, really easy to forget that. Make sure you pay attention, don't leave that out. Let's plug these in. Plugging in a 1, I get 62. Plugging in a 0, I get nothing, so that part's done. Over here, plugging in a 2, I get 62 times 2. 62 times 2, 124. Well, maybe I'll put these chunks in parentheses. Minus 3 cosine 2. Minus, when we plug in the 1, 62 minus 3 cosine of 1. Okay, so it looks like I'm going to need a calculator for this, because it's actually a real-world example. Make sure that your calculator is in radian mode. If we're not told otherwise, we're going to assume that it's radian mode. Okay, and so I'm getting all set here. Okay, and let's try it. Don't forget that it's over 2. So what do I notice? I've got 62 and a minus 62. And I've got 124, okay, so I don't know what to do with that yet. 124 minus 3 cosine 2 minus a negative is plus 3 cosine 1 over 2. So calculator time, because I'm done with my simplification. So 124 minus 3 cosine 2 plus 3 cosine 1, and we're going to divide that by 2, and I get 63.4 miles per hour. Okay, so what does it mean? It means that we sped up. Okay, so at that time we started at 62. In that last hour we sped up a little bit, so the average speed over the trip was 63.4 miles per hour. Hope you enjoyed this video, and I know a lot of you are working on your math papers right now if you're in the IB class, so think about, for a handful of you, how this could be useful in your exploration, because there's 4 or 5 of you that are going to need this exactly. Hope you enjoyed it, and we'll see you next time.